Welcome to this video on the hormonal regulation and physiology of the menstrual cycle, part of the M101 lecture series, Unit 2. The menstrual cycle is a coordinated reproductive process involving complex interactions. While we often recognize it as uterine bleeding, it is actually the result of integrated activity between the brain, ovaries, and reproductive tract. This pathway begins in the brain, with the hypothalamus and anterior pituitary establishing signals. The ovaries translate these into development and hormone secretion, while the uterus, cervix, and vagina provide the response and necessary passage. Consequently, textbooks present menstruation not as an isolated uterine event, but as an integrated process involving the hypothalamic pituitary ovarian uterine axis. This system links neural regulation with ovarian activity. The hypothalamus releases GnRH, which signals the anterior pituitary to secrete FSH and LH, prompting the ovaries to produce estrogen and progesterone. Ovarian hormones influence reproductive tissues while providing crucial feedback to the brain. Normal cycling depends on every part of this system. If one component fails, the entire process can be disrupted. The hypothalamus is the highest regulatory structure for this cycle. Its primary role is the secretion of gonadotropin-releasing hormone, or GnRH. GnRH travels to the anterior pituitary via specialized portal circulation. By stimulating the release of FSH and LH, the hypothalamus acts as the functional bridge between brain regulation and ovarian activity. At puberty, reduced sensitivity to estrogen allows for cyclical activity to begin. The hypothalamus also adjusts its output based on feedback from the ovaries and pituitary hormones. The hypothalamus does not just initiate the cycle. It continually regulates the timing and intensity of ovarian stimulation throughout the entire process. The anterior pituitary gland is the second major structure in this pathway. Responding to GnRH, it secretes two vital gonadotropins, FSH and LH. FSH is critical early in the cycle, as it drives the growth and maturation of ovarian follicles. As these follicles develop, they produce estrogen, which begins to affect the uterus. Luteinizing hormone, or LH, is especially important at mid-cycle. A surge in LH triggers ovulation and later supports the transformation of the ruptured follicle into the corpus luteum. By managing the timing of FSH and LH, the pituitary coordinates the follicular and luteal phases, ensuring that hormone production and uterine preparation occur in the correct sequence. Moving to the ovaries, these paired glands perform essential gametogenic and endocrine functions. They house the female germ cells while producing estrogen and progesterone, which regulate the uterine cycle. The ovarian cortex serves as the site for follicular development. Under gonadotropic stimulation, a group of follicles is activated, leading to the selection of a dominant follicle for eventual ovulation. As follicles grow, they function as temporary endocrine structures by secreting estrogen. Following a surge in luteinizing hormone, the mature follicle ruptures to release the oocyte. Post-ovulation, the remnants of the follicle transform into the corpus luteum. This structure produces progesterone, shifting the endocrine environment and regulating the uterine lining during the luteal phase. Finally, an ovarian follicle consists of a developing oocyte supported by somatic cells. These cells respond to gonadotropins and are vital for steroid production, driving the follicle's transformation from primordial to mature.